F prime.
Right, there's just a time.
Okay, that just means take the derivative. I could write this out, d dx of x cubed minus d dx of 4x minus d dx of 5, but I think we're beyond that right now. What's the derivative of x cubed? 3x squared. Now, careful your signs here. What's the derivative of negative 4x? Negative 4, right? It'd be x to the 0 power, which would just be 1, right? What's the derivative of 5? 0 plus 0, okay? What do you guys notice about the powers of your derivative versus the power of your function? It better be 1 less, right? Because you're always subtracting 1 power. So the highest power is a 3. That means in your derivative, your highest power better be a 2, right? Okay. That gets confusing if your powers are in the denominator, because it actually be 1 power higher in the denominator, but it's actually 1 power lower, actually, right? Okay. Is this in a convenient form? I think it's all right. We see this as negative 1/2, right? Times x to the 4th. I think we're all right with that. So g prime. So sometimes I'm going to take my time and write things out, because sometimes you try and math too quick and you just get burned, right? So negative 1/2 times 4x cubed, right? Plus, now there's your coefficient out in front. That's your constant multiplier. 3 times the derivative of x cubed. So 3 times 3x squared, right? And then what's the derivative of negative 2x? Negative 2. Okay, so taking this one step of writing things out and then simplifying, it's not going to cost you too much time to write quickly. All right, what would that be? Negative 2, x cubed, and then 3 times 3 is 9, x squared, and then minus 2. It's 1 power lower. Yup. Okay, we good? All right, now we're going to get into a spot where we have a whole bunch of terms. We need to rewrite these right now. Now, this is a fraction. This is a quotient. We do not have a rule for dealing with quotients right now. We only have a rule for dealing with individual terms. So we have to create individual terms. That means we can't have products unless it's a constant multiplier, and we can't have quotients. So we have to use our algebra skills to rewrite again, okay? So if you notice, we have 1 term in the denominator. You can always split this up. It's like unadding fractions. Well, that's just x cubed over x minus 4x over x plus 5 over x. Now, if you added these 3 fractions together, you would get this quotient, right? That's nice, because now we can use our other algebra rules to write this as 1 base of x to a power. So that would be what? X squared minus, that would be what, 4? And what would 5 over x be? (5x negative 1 power), yep. That x needs to get out of the denominator, it needs to be up at the normal base level or the top, which is the base level, right? And you have the power appropriate. It's okay to have negative powers, it's okay to have fraction powers. Now we can find the derivative, okay? This was only rewriting. We did not take a derivative yet. We're just setting this function up so we can take the derivative nicely and quickly. All right, the derivative then. Okay, take the derivative of each term. That's what our sum of difference rules say. Derivative of x squared, 2x. Okay, derivative of negative 4, 0. I love constants when we take the derivative, right? Okay, derivative of 5x to negative 1. Okay, negative 5x to negative 2 power. And then let's write all our derivatives without negative powers, please. Minus 5 over x squared. Now, in the future, we're going to want to combine these back together to make 1 fraction so that we can write everything in factored form, factor top, factor bottom. For purpose, we're going to be doing a lot with this. But for right now, I'm okay with just writing everything with positive exponents. Okay, your book, if you check the answer key in the back, they might combine this into one fraction and factor everything. Just be mindful of that, and it's good practice to do too, actually. Okay, fun fact. What value of x makes the function undefined? 0, right? So if the function is undefined, when is this function not differentiable? At 0. If the function is not defined at 0, that means it's not differentiable at 0 too, right? We gotta keep that in mind. They might ask us questions like that. And honestly, can you plug 0 into the derivative? Nope, because it makes the function undefined here. And the derivative is a function itself. Okay? Now what about g of x? Part B, g of x. We got x squared plus 1 times x minus 3. We have a product. We don't have rules for that yet. We will later. But how can we take care of that right now? We have to write everything in terms, right? Single terms. I better multiply this out. All right. What's that? X cubed minus 3x squared plus x minus 3. A little bit of FOIL action. Some teachers are going to hate that I say FOIL. That's okay. G prime then is, quick. And 0. Good. All right. Pretty quick, right? If we use the limit process on this one, it'd take forever. This is a lot quicker. Okay. All right, real quick. Letter C. So what do we focus on now? Okay, number 1, we're focusing on looking at the function and making sure it is written in a form at which we can apply the power rule. This one is obviously not, so what we got to do? Got to expand it. All right, this is the third power. Go ahead and use your math muscle or just learn how to do Pascal's triangle. This is 0 row 1, 2, 3. So let's look at our coefficients. F of x will be 1 times x cubed, and that would be negative 3 to the 0 power, plus 3 times x squared, negative 3 to the 1 power. And I always put parentheses around that, and then I'll go through and move my coefficients appropriately. 3 times x, and then negative 3 squared, plus 1, x to the 0 power, negative 3 cubed. Okay, start out with cube on this one, 0 on this one, decrease 1 power, increase 1 power. Okay, and these are the coefficients. All right, simplify a little bit. That's x cubed. Would that be negative 9 x squared? Okay, negative 3 squared is positive 9 times 3 is 27. And then negative 3 cubed. 3 times 3 is 9 times 3 is 27, but it's negative. Okay, again, expand and then take the derivative. We have powers written. Now we can use our power rule to take our derivative. We're using our sum and difference rule because we are taking the derivative of each term independently of the other one. Okay, can we go quick again on this one? Ready, set, go. 27. You guys tailed off in the end there. I couldn't hear anything. I'm getting old. Are we good? Pop quiz. What's the second derivative?
What? 6x minus 18.
There you go. That's it. We haven't done anything with that yet, but using our critical thinking skills, we can kind of expand, right?
That's 6.
Would be what?
6.
The third derivative? What would the fourth derivative? Now, check this out. Sometimes we don't go 4 tick marks. We'll put like a little 4 up here. Sometimes it's in parentheses. That's not f to the 4th power. In context, that's a fourth derivative, which would be
0.
So eventually, all right, you have one term in the denominator. This problem's easy. Yeah, it looks confusing, but it's easy. You can just break it up, right? And I like to go x to the 1/2 power right away because I know I'm going to be subtracting powers. Thinking about your next steps while you're doing something, while you're doing the algebra, set it up for success in your next step. Try not to be too fancy and do too many things at once. Like write everything out. Okay, what do you got? Would that be 2x to the what power? What, 3/2? 2 is 4/2, so minus 1 would be 3/2. Minus 3x to the half. Okay, that means g prime then. All right, 2 times 3/2, drop the power down. As a multiplier, subtract 1 from 3/2 gives me 1/2. Minus 3 times, multiply by the power, subtract 1 from the power. Simplify a little bit. Okay, 2's canceled. They multiply to 1, divide to 1. 3x to the half power minus 3 over 2x to the half. Put that downstairs as negative power. And then obviously we could write it as such. And we know since there's a radical in the denominator, maybe the answer choice on a multiple choice question would have a rationalized term here. We've talked about this. It's okay to leave things in this form. Again, back to the book. Maybe they had a common denominator. Maybe they made one fraction out of this and they factored some things. So just keep that in mind. Okay? Questions at all? We're good? Everybody's favorite trig? Something you have to have memorized. If you don't, life's going to be rough for a while for you. d dx of sine of x means the derivative of sine of x equals cosine x. The derivative of sine is cosine. But the derivative of cosine is the opposite of sine, so negative sine. What's the derivative of tangent? We can't do that yet. Why? Because tangent is sine over cosine, and that's a fraction, that's a quotient, right? We don't have a quotient rule yet, so we can't figure it out. In due time, friends, we will figure it out, though. All right, the derivative of sine, well, let's use the limit process. Delta x goes to 0, and then be sine of x plus delta x. So f of x minus plus delta x minus f of x all over delta x. We got that. We know what that is. We've practiced that before. If you're looking at this and like, what is going on here with this? You need to get some extra help so you learn this, okay? You have to know what's going on. All right, the expansion of this is a sine alpha plus beta problem. You can't just distribute sine. Doesn't work that way, but I will show you what happens. Delta x goes to 0. It's actually going to be sine of x cosine delta x plus cosine x sine delta x. If you have a sum or a difference in the argument of the trig function for sine, this is the expansion actually. And then minus sine x all over delta x. All right, here's the deal, guys. We have sines and cosines and stuff. We have to remember our special limits. What is sine x over x equal to? The limit as x goes to 0.
1.
Okay, how about the cosine 1? What does the cosine 1 look like? It equals 0, but what is it? What is it? What is the cosine?
1 minus sine of x.
Nope. minus what? Cosine x over x, the limit as x goes to 0, right? Okay. Well, we need to try and create some of these situations, okay? So let's start by doing some fun stuff here, and let's move. Well, we got a sine x here and a sine x here. Let's take these two terms, put them next to each other so that we can factor them. So we got sine of x, cosine delta x, minus sine x, and then we're going to put plus cosine x, sine delta x. And let's do this. Let's break it up into two fractions for fun also right now. Delta x, delta x. Now we have two terms, so I got to put parentheses around this garbage. Let's factor out a sine of x. Sine of x. So that'd be cosine delta x minus 1. Ooh, that's kind of fun. It's looking kind of like this, right? And then we got cosine x. Well, we have a sine of delta x over delta x also. We're kind of setting up these limits. Okay, well, here's the problem though. This is kind of backwards, right? It'd be nice if it was positive 1 and a negative cosine. Well, we can do that mathematically, right? We can switch it. How can we switch it? Yeah, factor out negative 1. So this is going to be negative sine of x then times 1 minus cosine. And with purpose, I can put the delta x just under this one, right? And this is a product, right? Plus, now with purpose, let's set this up. So it'd be cosine x times sine delta x over delta x. Now, a nice thing about limits, if you have a product, it's just the limit of each term, right? Each part, each factor of that product. If you have a sum or difference, it's the limit of the sum or difference, right? So we can actually apply the limit to everything. I'm going to write it out once. Of negative sine x times the limit as x goes to delta x. Well, I'm sorry, delta x goes to 0. What am I doing there? 1 minus cosine delta x plus limit delta x goes to 0 cosine x times limit delta x goes to 0. Now, will you ever have to reproduce this on an AP test? Probably not. But it's kind of nice in these advanced math classes, you get to sit through this a little bit. Yeah.
Could you separate the negative and the sine?
Could you do what?
Could you separate the first term as well?
This one?
Yeah.
Put the negative out in front?
Yeah.
Yeah. Yeah, because that's the negative 1 times sine of x, right? That's a constant multiplier. You can put it out in front. All right, let's go through this. What is this? Well, it's delta x going to 0. Do you guys see a delta x anywhere? So that's just negative sine x. Times. What is this limit? It does have a delta x in it. Zero. Looks like some of us better make some flashcards. Memorize those. What's the limit as delta x goes to 0 of cosine x? Cosine x. There's no delta x to make a substitution, so it's just going to be the arguments of the limit. Now, what is this one? 1. Negative sine of x times 0. Cosine x times 1. There we go, guys. The derivative of sine of x. And we already have it written up here. I'll just write it down here because we can't see it right now. All right. that was kind of fun. Good math. Questions on that at all? And if you do not have these memorized, that's on you guys. Memorize them, okay? Do something. There are plenty of activities you can like practice on your own. Write flashcards, write it out, just learn it.